Okay, looks like the top got cut off, but that's the 6.3 and 6.4 part 2. Integration versus total area. When we take the integral, when we integrate, what are we finding?
Area under
Under what?
a line.
A line or a curve. We're finding the area, right? And this is actually, it's the net area, net area to the x-axis, right? Because when we found the area of sine from 0 to 2 pi, we said the area was 0. Do you remember that? So this is the net area above the x-axis. So sometimes the negative area cancels out the positive area. We get 0, even though we can see there's actual area. So integration is the net area above the x-axis versus total area is gross area. Who has had a job where you get a paycheck and taxes are taken out? I've heard of people who have had a job. What? Okay. When you get your paycheck, originally you're paid so much. And then, if you're in desperate need, you can go down to the office and get us a new box. I don't think I have any more tissues. Oh yeah, you get your paycheck, and say it's for $300. Do you normally get $300? No, you might get like $200. Why? Taxes. The government takes taxes. And so we have our net area. That's your $200 after taxes, but your gross, your original all-encompassing area was the $300, right? So this, though, is always a positive value. Okay, so we're going to look at what's the difference. So graphically speaking, what's the difference between evaluating an integral using Riemann sums, the rectangular approximation method, versus using an antiderivative. If we have this integral 1/4 x squared integrated from 0 to 6 from L round with width n equals 3. No, the width isn't 3. We have 3 rectangles. What would the width be? 2. And if you're still fogging how we get that, we take the bounds and divide, 6 minus 0, divide by the number of rectangles, and we get 2. Okay, would you draw on your rectangles on that one, showing left rectangular approximation method? Okay, so your first rectangle should be from 0 to 2, that's flat, right? And then from 2 to 4, just height of 1, and then from 4 to 6 with a height of 4. Is this an over approximation or an under approximation? Under approximation. What would give us a better approximation? More rectangles. Let's do n equals 6. Okay, Joanna, if we have 6 rectangles from the limit 0 to 6, how wide would each rectangle be? 1. Good. Width of 1. Still with the left left endpoint. It's still under approximation, but is it a better approximation? Are we encompassing more of the area? Yeah. What would give us a better approximation? antiderivative, because the more and more rectangles we add in, the more accurate we are, right? So the antiderivative has the width of, each rectangle has a width of 0. Why would we say it has a width of 0? Rectangles. But yeah, exactly. Infinite number of rectangles.
The reason 1 over 0 is undefined is just ending sensation.
Mm-hmm. So even though this looks pretty dang close to all the area, am I still missing some? Yeah, you have to have infinitely many rectangles, and that's what the antiderivative does. Is it gives us a dx, which is your width. Remember, dx is always your width, which is why that has to multiply everything in parentheses. Versus our approximation is always going to be, in this case, an under approximation. If we did a right endpoint, we have over approximation. More accurate one is antiderivative. Okay. So on the next problem, what is the height, if this is our function f of x, what is the height of our rectangle? Yeah, which is just, but we can see that, it's just 4, right? Because we have 4 minus 0, because the bottom is 0. Top minus the bottom. What is the width of the rectangle? 2. How do you find 2? 6 minus 4, which is the right minus the left. Right minus left. 6 minus 4, 2. So what is the area of the rectangle? 4 times 2, right? Which would be 8. Okay, in general terms, the height is something specific in our integrand. The height is the height of the function, f of x. What's the width called? I just said this a minute ago. dx. So the area is the function f of x, and it has to be times, because it's length times width, times d of x. dx, not d of x, dx. Good? Okay, number 1. Graph y and shade the indicated region from 1 to 4. Okay? What type of function is this? What type of function is that? Quadratic. Why do we know it's quadratic? Because we have 2 x's, we multiply it so it becomes x squared. So isn't this the same as y equals negative x squared plus 3x? Okay? You can either plug in 1, 2, 3, and 4 into the original, into the new, or you can know where your axis of symmetry is to graph it. There's lots of different ways to form the graph. Do you remember how to find the axis of symmetry on a quadratic? It's the beginning and the end of the quadratic formula. Because your vertex is on the axis of symmetry.
It's square root of b squared minus 4ac over 2a. Okay.
What's the beginning, though? You missed the beginning. X is equal, it's the beginning and the end. X is equal to negative b all over 2a, right? When it's in standard form like the one I wrote in blue, you can plug it into negative b over 2a. Probably the easiest way, and probably the method you would do that's quicker, is just take your 1, plug it in, take the 2, plug it into the original, 3, plug it in, 4, plug it in. And then once you see the symmetry, you can just follow it. If I plug in 1, what do I get? Two? I'm not sure it's 2. Negative 1 squared plus 3 times 1. We have, oh, maybe it is 2. Oh, this graph I have here is wrong. Then negative 1 squared. Yep, and if we plug it in here, we have negative 1 times 1 minus 2 is negative, yep, okay, 2. Okay. What do we get when we plug in 2? Negative 2 squared plus 3 times 2. Negative 4 plus 6 is, why are we getting all these 2's? Really? Interesting. That's not what I have on mine. Okay, what about 3? If we get 2, something's going weird. Okay. Plus 3 times 3, 9, yep, 0. And if we plug in 4, negative 16 plus 12, negative 4. Let's see. Our vertex looks like it's somewhere between 1 and 2 then. Axis of symmetry, negative b. What's b? 3. So we have negative 3 over 2 times a, which is negative 1. Oh, yep, it is. 3/2. So our vertex is somewhere in the middle. 1.5. If we plug in 1.5, what would we get? 1.5 squared plus 3 times 1.5. Negative 9/4 plus 9 over 2, 18 over 2, negative 9 over 2. Is it 4.5? I don't know. Someone calculate that for me. What do we get when we plug in 1.5? Negative 9/4. Oh, okay, so that is up here somewhere. And we just need the area from 1 to 4. Okay, all we're doing is shading. Will you do number 2? Figure out what that graph looks like. And shade it on from 2 to 4. What type of function is this going to be again? Quadratic, so 2x is being timed. You can use the 0 property and be able to tell us 2 of the x-intercepts. Claudia, what does this factor show the x-intercept will be? And this one is 3. Good. So we know we have an x-intercept there and there. Okay, so you just need to plug in 2 and plug in 4. What do we get when we plug in 2? -1. And what do we get when we plug in 4? 3 times 1 is 3. Yep. So -1, plug in 4, we get 3. So our quadratic looks something like that, and it should be concave up, opening up because we have a positive x times a positive x, that should be a positive x squared. So our area from 2 to 4 for the shading is this section to this section. Okay, now if we just did the integral, both of these, the negative area cancels out some of the positive area, which is different than how we've done the total area, because this area underneath the curve, if we're looking at total area, is considered a positive area, even though it's signed to be negative. And this area underneath the curve, if we're looking at total area, is actually a positive real area value, okay? Even though it's underneath the curve, so if we were doing the integral, the sign would be negative. Okay, next column, number 3. Graph y on the shaded and shade the region from 0 to 6, and then we're going to evaluate the integral. Okay, y equals 4x minus x squared. You see a minus x squared, what type of graph is it going to be? Yeah, concave down parabola. Okay, and could we use the 0 property if I factor out an x? Actually, maybe I want to factor out a negative x. Then I have x minus 4. Using the 0 property, you can easily see the x-intercepts. Ethan, what would the x-intercepts be? Good, 0 and positive 4. And somewhere in the middle, we have, because of symmetry, we have a maximum. So I would plug in 2, and then you know the maximum. When we plug in y equals 4 times 2 minus 2 squared, you get 8 minus 4, which is just 4. And looks like my graph only goes to 4, but our bounds go to 6, so I need to extend that a little bit. And then we need to plug in 6. 4 times 6 minus 6 squared. 24 minus 36 is 12. So way, way, way down there. Okay, but the area from 0 to 6 is all that good stuff, all the way down to negative 12. Okay, evaluate the integral with you can use your calculator on this one. You can also do it by hand. Either way, no matter which way you do it, with your answer, what should be in front of the answer? The definite integral. Especially if you use your calculator, you need to have the definite integral or you will not get points. From 0 to 6, what comes after the integral? 4x minus x squared. What's wrong with this? Parentheses, exactly. Why do I need parentheses? Because it's what? Okay. Because what are we doing with doing an integral? We're finding area, aren't we? An area is length times width. dx is your width. The 4x minus x squared, or the function, is your length. So you have to have all of that being multiplied. Okay? So you go to math, number 9, I think it is. What do we get when we evaluate the definite integral using the calculator? Equals 0. Why do we get 0? I see a shaded area. Why do we get 0? Yeah, we have this positive area, and we have some negative area, but they happen to be exactly the same. Since one is positive and one is negative, they cancel out to 0, which is different than finding the total area. Okay, if we found the total area, as we put on the first part, the total area is the gross area is always positive. No, not 24. Okay, we have two sections. The first section, the positive section, goes from, what's the lower limit to the upper limit? 0 to 4. So we're going to find them in sections from 0 to 4. Okay, top minus bottom. We have the top of this is our function, 4x minus x squared, to what's the bottom of the function? What? What's the line? What's this line? It's y equals 0 dx. Plus, we have another section. So these are, because it's top minus bottom. Because we'll be doing some later where we want to find the area, this area. Top minus bottom. Okay, and we have a second section. After 4 until 6, we have this negative signed area. Top minus bottom. What's the top function? Y equals 0. Minus the bottom function. That curve. What's the function for that curve? Yeah, and make sure you put all that in parentheses because we're minusing all of it. Dx. Back to your left-hand column, my front side. Okay, top minus bottom. Make sure you do top minus bottom. So if we integrate from 0 to 4, of 4x minus x squared dx, what do you get with that? You can type this one in your calculator, as long as you write the integrand. Jake, have you figured it out on your calculator? Yours is different. Okay. 4x minus x squared, comma, integrating with respect to x, comma, lower limit 0, comma, upper limit 4. I get 10 point, what's the exact value though? 10.6.
10.2.
Okay, that would be an exact value, yep, 10 and 2/3. What's another exact value? A line, it's a repeating decimal, and we can write that. Plus, interesting, this one has a constant out front that can be multiplied out front. What's the constant in front of this integral that can pop out front? Constant. Well, doesn't it have a negative 1? So instead of plus, this is actually minus the integral from 4 to 6 of 4x minus x squared dx. Okay, why does the second integral have a negative in front? Okay, and when you do this integral, what number do we get? Well, it's from 4 to 6 instead of 0 to 4. Do we get the same number? Do it again. And I can just go second enter and just change my limits from 4 to 6. What do we get? So we're minusing a negative 10.6. So again, why does this have to have a negative sign? Why does that negative come around and pop out?
Oh, because that changes that negative number to positive.
So your total area is positive, because total area can't be negative. Total, if we do top minus bottom, that second piece, if it happened to be a negative piece, it will force it to be positive, plus 10.6 repeating, okay, which is, let's see, 10 and 10 is 20, 2/3 and 2/3 is what, 1 1/3? So 21, 0.3 repeating, the area. And that's it. Is it okay to leave an equal sign on that one? Okay, if you round it, you would have to say approximately. If I said 21.3333, then I would have to put approximate. There's a difference between equal and approximate. Is it the same? Part B, where we evaluated the integral, did we get the same thing? It's the total area. No, one is 21.3 repeating, the other one is 0. Because this is the total area, considering all area to be positive. And that is the signed area, which it cancels out. Okay, would you and your neighbor please go try number 4? X squared minus 3x. Y equals x squared minus 3x. Graph. Evaluate the integral and evaluate the total area. When determining the total area, on the side it says, draw the representative rectangles so you can see which, if it's positive or negative. Factor out the negative sign like we just did. Okay, evaluate the integral and the total area. Mm-hmm. Yep, make sure you always do top minus bottom. That looks good so far. Actually, this should just be 2, 3. Is that first section? 1, 2, 3. So that should be 0 to 3, and then this should continue from 3 to 4. Can you what? Yep, good. Yeah. Okay. Ariel, when you have a sec, would you go draw the graph part that you have? The first step and shade it.
That's about 10.6. I got 10.6. Put in your freaking after I do this 2.6. Negative 2 points. Negative 2 points.
Great. And would you draw in the rectangles to show the sign? You just do a vertical rectangle and side up to the x-axis. Yeah, great. Okay, Ariel, pick someone to come do B. So yeah, show us your setup and your work for B on evaluating the integral. Well, so show me how you would tell the AP test grader that you put in your calculator. Okay, thank you, Claudia. Does that show the AP test grader that she put in her calculator? Yeah, because you have to show that setup. And if this was the test too, we'd box all of it up, including the integral, which this is just notes, but you also need to box up the integral. Okay, Claudia, pick someone to show us C. Jonathan. I'll move this down a little bit. C requires a little more work. It's not. So go up to the line tool and the top one, yeah. Yeah, I'm gonna have to write really small. Close it up, dx, right? Bracket dx. Okay. Alright, yeah. Okay. Now he did it in a different order than I did, but is it okay? Can we add in any order? Yeah, we have a thing called the commutative property of addition and multiplication. You can add in any order. So he started with the right side, 3 to 4. And the top is the curve, right? Minus the bottom is the x-axis. And the second one from 0 to 3, the top is 0, y equals 0, minus the bottom is the curve. Okay, so which one of these has a negative that pops out front? For his, it's the second one. If you did it in the reverse order, it would be your first one. It's the one that has the integral from 0 to 3. So we have from 3 to 4. Oh, there's a 4. X squared minus 3x dx, because the minus 0 doesn't do anything. But this guy has a negative that pops out front from 0 to, not 0 to 4, 0 to 3. Of positive x squared minus 3x dx. And those parentheses are important because it should all be times by dx. Okay, what did you get for this integral? Equals 1.83 repeating minus that integral. Negative 4.5. So with both of them minus and negative, we get a plus. .3 repeating. That's the exact value. If you round it, you have to put approximately 6.3333. But if you put the exact value with the repeating bar, you have to have the repeating bar, then you can just put 6.3 repeating. Any questions on that? Okay. So again, the first one, why is the first, well, in John's case, it ended up being the second one. But the first section, why did this first section end up having the negative sign that popped out front? Because it was the negative area, and to make it positive, it pops out. So notice, whenever it dips below the x-axis, same with this one, it was this section that dipped below the x-axis, that's the one that had the negative pop out front. Okay, flip it over. Now we have one that's not the x-axis. Okay, still, same deal though, top minus bottom. We want the total area of the shaded region. Okay, is this area a positive area or a negative area? Positive area, because it's above the x-axis. Sign of it would be positive. So it's still the same thing, top minus bottom. How many sections do we have? Shaded area, how many shaded sections? Only one actually. Yep, from what's our lower limit to our upper limit? 1 to 4. Top minus bottom. Alex, what's the top function of the shaded area? Good. Minus the bottom, which would just be y equals 4. Now, had there been more with 4, parentheses definitely would be important. But just 4, you don't technically need those parentheses.
Wait, how come it's not? How come it's not 4 by 3 for the total area underneath?
Because we're not going all the way down here. We're stopping here.
So what I'm saying is, if we just found the area for negative x squared plus 5x, we would find everything underneath. So wouldn't we have to minus everything underneath the line 4 to just get what's above it?
Well, that's what this is. Minusing, this is doing the integral of this one by itself,
Oh, under the
minusing the area underneath the 4. So it is doing that.
Okay, got it.
So that white rectangle is what this is minusing. Okay, so we can combine them though into one big one. From 1 to 4, we have negative x squared plus 5x minus 4 dx. Okay? Good. Is it supposed to be positive? Because total area should be positive. Equals 4.5. If you show that you set up your integrand, I should probably have boxed in the A too. If you show you set up your integrand, then you can use your calculator if it's on a calculator section. Okay. Now, what if the graph had not been so clear as to where these intersect? How would you know where they intersect? How do you know when any two graphs intersect? Yeah, it's when they're equal, right? So if it wasn't as clear, you'd set both functions equal to each other. So you do negative x squared plus 5x equals 4, and you'd solve for x. How would you solve for x on this quadratic? You could complete the square. I would not choose that, but you could. If you're comfortable with completing the square, by all means, do it. Okay, I would move everything to the right side so we have a positive x squared. And make it 0 equals positive x squared minus 5x plus 4. So I added the x squared over and I subtracted the 5x over. Well, completing the square has to have x's on one side and constant on the other, but this has to be a positive 1x. If I was doing completing the square, I would have divided by negative 1 and on everything. Not on completing the square. Constants have to be on one side for completing the square. This should factor nicely. What two numbers multiply to 4 and add to negative 5?
Negative 1.
So instead of telling us x-intercepts this time, using the 0 property, we get the x-intercepts instead of the x-intercepts on the x-axis, we get the x-intercepts of the two functions is at 1, x equals 1, and x equals 4, which are the bounds we used. Okay? So, same thing on the next one. Number 6. Yeah, this is weird that some of it is like cut off. Oh, that's on number 7. Find the total area. We have x squared minus 4. Do you guys know how to factor that? To find the zeros? Minus 2 and plus 2. So we have an intercept at negative 2 and positive 2. And it's a quadratic opening up. And y equals 140 is somewhere way up here, right? Y equals 140. Whoa. I don't know how that happened. Okay, it says find the area trapped between the curves. Where would that area be? Trapped between the curves. Is it from here to here? Is it all of this stuff inside, like a vase, kind of? Yeah. All of that. How many sections are there? How many sections are there? One. These were two different sections that this one's all positive area, this one's all negative area, but they're separate. You can't do, I guess you could if you wanted, but it's way too much work to do like this section. Are you saying two because of like that? Yeah, it's just one big section from this intersection to that intersection. So we need to just find out what this intersection is to that intersection. How do we find where these two graphs intersect? Yep, set them equals to each other. X squared minus 4 equals 140. Find out where they're going to intersect, at which x coordinate. Once you have those, evaluate the integral from the lower and upper limits that you found. What are you guys all dressed up for today? Basketball? Oh. Do you guys do this like once a week? Once a month? And you have a class B days? That's why I always see it. Okay, Joanna, what did you get for your intercepts? X equals what? 12 and? There are two of them, aren't there? There's one over here, plus minus 12. So that is negative 12. This one's positive 12. So your integral from negative 12 to positive 12 of our function x squared minus 4 dx is what? Oops. Technically what I wrote was fine, but what is yeah, no, the top is, so actually what I wrote is not fine, sorry. What is the top function? 140 minus the bottom function is the curve. So here parentheses are important. X squared minus 4 dx. Okay, so if you type that into your calculator, you would do parentheses 140. You can do it this way, but make sure it's a plus 4, or you can rearrange it into standard form. So what do you get? Alex, you had it right? Does anyone else get 2,304? Yeah.
Okay, so minus the top and the bottom, I get that.
Mm-hmm.
But the area, so like area under 140 is like a box. And then if we minus the function, when we get the area outside of the function, because we just minus it from the rectangle. You know what I'm saying? So if you drew the area of 140, and then we minus the area, we'd only be left with like...
Well, the area of 140 only goes there. You're worried about minusing this area?
Yeah, like, isn't that what we'd be left with? Because we just minus the parabola, so we're left with that, and then what's underneath the x.
We just subtracted... Gosh. So we do the area under 140, which is negative 12 to 12. Yeah? And we just subtracted x squared minus 4.
So that's what cut off of the area.
Mm-hmm.
So when we be left with what's out.
But x squared minus 4, so this is x squared minus 4 is a positive parabola, but we're subtracting its total area. Kyle, you make things difficult.
Sorry.
You really stretch my mind, which is good,
zero,
but
I don't.
no, it's not 0. From negative 12 to 12.
It's okay.
But that also includes this, which the box didn't include.
If you tell me that bottom was the right answer,
It's right.
But I'm just in my brain. It doesn't.
Okay, I'll think of a way to figure out. This last one you asked for, I was able to explain that one. Was it that one? Because we were subtracting the white rectangle. I'll have to think about how to explain that one for you in a minute. Okay, let's continue. We have 2 more, I think, right? Okay. Okay, we're just going to set this one up, not evaluate. This got cut off. Oh, and it's a cube. A cubic. Y equals x cubed minus 8. Do you remember what cubic functions look like? And the minus 8 is a vertical shift on the y-axis down to negative 8. So normally cubics cross at the origin. This cubic is going to cross at negative 8 now. And then we have some line up here, y equals 19. And we're finding not just the area under the curve, but the area trapped between the 2 of them. That's why I have to do top minus bottom. Before we were doing just area under the curve, the bottom was y equals 0. Okay, but now our bottom is y equals x cubed minus 8. So the setup would be, Jake, can you tell me how I'd write the setup?
So you do. Wait, why are we doing it just from 0? Since right side of black, something like that. Gotcha. So you do the original thing you went from 0
to whatever this is, right? How do we find that? Set them equal to each other. X cubed minus 8 equals 19. Since there's only one x term, you can add the 8 over and solve for x using roots, but not a square root. It would be a cubed root. So we take a cubed root, so you have to have a 3 as your index. And you're thinking, what number times itself 3 times is 27? What about negative 3? Should this be plus or minus 3? Negative 3 times negative 3 times negative 3, is that positive 27? No, that'd be negative 27. So in this case, there's only 1. So it would be 0 to 3. Okay, Jake, continue. Make sure you do top minus bottom. Ah, I was going to trick you, but you caught it already, in parentheses. Times what? Dx. So there's our top minus the bottom. Okay? And one more, number 8. This one we'll actually evaluate. Okay, negative x squared plus 2, and y equals x on the interval 0 to 3 for only the first quadrant, which is from 0 to 3 anyway. Okay, so obviously the curve is the quadratic, and the linear is x. How do we know this point? set them equal to each other. Negative x squared plus 2 equals x. I would choose to make the x squared positive, so I'd move everything over to the right. Get positive x squared plus x minus 2. You guys okay if I skip the step that shows how I did that? I just added that and I subtracted that. Then you factor. Just attempt to factor. Two numbers that multiply to a negative 2 that adds to 1. To a negative 1. So x plus 2, x minus 1. So using the zero property, we would get x equals negative 2 and x equals positive 1. Which one represents this x value? So where is the negative 2 at? Yeah, because this graph goes like this, and somehow they're going to intersect again. And that would be at negative 2. But we only want from there to here. And that would be at 3. Okay? So Ethan, we are setting up this area. How would you go about that? Remember, top minus bottom. Does that top function go for the whole section you've done from 0 to 3? I would do the first one from 0 to 1, because we actually have two different functions on the top, right? So from 0 to 1, the top function is that quadratic. Minus the bottom, which is x equals 0. Close it up, and then what comes after the parenthesis? Dx. So this one has two sections because the top function, we have two different top functions. Plus, keep going, Ethan. Dx. Top minus bottom times dx. Okay? So find the area from 0 to 1 and from 1 to 3. Add them up, and we have the total area. Nope, it is a 2. I thought I was missing it, but it is a 2. X, comma, from 0, comma, 1. Oops, I did something wrong. Oops, that's what I did wrong. (1.6) repeating, plus math number 9 of x, comma, 1, comma, 3. So, I can put it right here, equals 5.6 repeating. Okay. So, now you should be able to finish 5.3 and 5.4. I'm guessing we won't have time with the test, as the other tests have shown. If we do, great, we'll answer some questions on 5.3 and 5.4 next time. If not, we'll answer them on Tuesday, and then they'll be due the following Thursday.
When do we use this just going to ask for total area?
We're going to ask for total area, yep. Yep. Yeah. for questions on the review? Yeah. Let me get this out of the way first.